Hi, welcome to introductory session on projection of solids. So, in this session I would like to cover what do you mean by solid, that is definition of solid, and what are the different types of solids, means classification of geometrical solids, and what are the different parts and its names, and we will conclude this session with definition of orthographic projection of solids. Now, to start with, what is a solid? See, already we have defined what do you mean by a plane in the previous session. A plane is a two-dimensional object which is having only two dimensions, that is length and then width. It does not have any thickness. The example for different types of planes are, it may be a square lamina, a square plane, triangular plane, pentagonal plane, hexagonal plane, circular lamina, etc. Similarly, a solid can be defined as it is a three-dimensional object, means it is having all the three dimensions, that is the length, the width and the height or the thickness. Therefore, we say that a solid is a three-dimensional object where it is having all the three dimensions like length, width or and the height. And we say that the solid is bounded by either a flat surfaces, you can see all these are flat surfaces. So, a solid is formed or bounded by a flat surfaces or a curved surfaces. For example, for a curved surface you can take it as a sphere, where the complete surface will be a curved surface, or a combination of curved surface and flat surface. For example, if we take this particular solid, it is a cone where it is having a curved surface, it is bounded by a curved surface and a flat surface. Similarly, if we take a cylinder is also bounded by a curved surface and top and then bottom are flat surfaces. So, a solid is formed or bounded with a flat surfaces, like it may be a prism or it may be a pyramid, or a curved surface like a sphere, or a combination of curved surface and a flat surface, like for example, it may be a cone or it may be a cylinder. So, this is the basic definition of a solid. In orthographic projection, we assume that a solid is an object which is placed in the first quadrant. So, now going to the next topic that is different types of geometrical solids or classification of geometrical solids. See, basically we can divide the solids into two types. One is polyhedron, other one is solids of revolution or rotation of solids. So, when I say polyhedrons, again in polyhedrons we have two types. One is a regular polyhedron, other one is other polyhedrons. Now, what do you mean by a polyhedron? A polyhedron is that solid in which it is bounded by only flat surfaces. For example, you can take a prism or you can take even a pyramid. See, all these solids are polyhedrons because it is bounded by only flat surfaces. Now, when I say regular polyhedron is again a polyhedron, means it should be bounded by only flat surfaces. When I say regular polyhedron, all the flat surfaces will be of identical shape and size. For example, you can take a cube. Cube is also called as hexahedron. So, when I say a cube, it is having 6 faces. Hexa means 6 faces, 6 square faces. All square faces are of same size. Then we say that it is a regular polyhedron. Similarly, we have another polyhedron like tetrahedron. When I say tetrahedron, it is a special type of triangular pyramid. When I say tetra means 4, so it is having 4 triangular faces, equilateral triangular faces. For example, if we take this is a square pyramid, right? But when I take a tetrahedron, the base of the pyramid will be triangle, equilateral triangle, and all slant faces will also be equilateral triangles. Totally 3 slant faces which are equilateral triangle, again 1 triangular face at the bottom. So, totally we will be having 4 triangular faces. So, that is what we call it as a tetrahedron, which is another example for a regular polyhedron. Now, coming to the other polyhedrons, I can say it is a prism and it is a pyramid. So, prism and pyramids are other polyhedrons, because it is also a polyhedron because it is bounded by only flat surfaces. Even pyramid is also bounded by only flat surfaces, but all faces are not same shape and same size. So, therefore, it does not come under a regular polyhedron, but it is a other polyhedron. Okay. So, in a as I told, in other polyhedrons we have two types, one is a prism, other one is a pyramid. So, this is about the polyhedron, regular polyhedron and other polyhedron. Now, coming to the another classification of geometrical solids, that is solids of rotation or solids of revolution. So, when I say solids of revolution, see in that particular thing, so we are going to take some laminas or some plane surface and we are going to rotate or we are going to revolve to generate certain solids. For example, some of the important solids of revolution or solids of rotation are cone. So, you can say a cone and a cylinder and a sphere. These are the three important solids of revolution example. Now, how this cone is formed? See, when you take a right triangular lamina and when you rotate, keeping the one of the edges of a right triangular lamina, when the hypotenuse is rotated, when it is revolved, so it is going to generate a right triangular lamina or plane surface is going to generate a cone. So, that is why it is called as one of the solids of rotation or solids of revolution. Similarly, we can also have a cylinder. In cylinder, what we do is, so we take a rectangular lamina, okay, we can take a rectangular lamina and then we can start rotating the things. So, when you start rotating, okay, so a rectangular lamina is going to generate, one of the edges of the rectangular lamina is going to generate a cylinder. So, a cylinder is one type of solids of rotation, and another one is prism, sphere. When I say sphere, again sphere is formed when you rotate either a circular lamina or a semicircular lamina. So, when a semicircular lamina or a circular lamina is rotated, the circumference of the circular lamina is going to generate a sphere. So, these are the different types of geometrical solids. Now, in the syllabus you have a few regular polyhedrons, like you have a cube, you have that is hexahedron, you have a tetrahedron, means you have tetrahedron means all four triangular equilateral triangular faces will be there. Then you have a prism, you have a pyramid, different types of pyramids again we have different types of prisms, and similarly you have a cylinder, you have a cone. So, these are the different geometrical solids where you have the problems. Now, before we go ahead with the orthographic projection of solids or the problems on projection of solids, so it is very important or it is necessary to understand what are the different types of prisms, what are the different types of pyramids, what are the different parts of it is very, very important. Now, coming to the prism. Now, you can see this is a prism. Now, what type of prism is this? It is a square prism. See, any prism if you take, it will have two parallel end faces which are parallel to each other and identical shape and size. So, depending upon the shape of the face, we are going to name the prism as square prism, triangular prism, pentagonal prism and hexagonal prism. Suppose if now in this case the base or the face of the prism is square, so we call it as a square prism. If it is a triangle, we call it as a triangular prism. If it is a pentagon, if the base is pentagon, it is called as a pentagonal prism. If it is a hexagon, then we call it as a hexagonal prism. Okay. So, now when you take a prism, so any prism will have some important parts. Now, if you take this is the corner, the base corners, these are the base corners and we call this as base edges or base sides. Now, we call this as lateral edge. We call this as lateral edge and top face. And very important thing is axis. So, what is an axis? It is an imaginary line passing through the center of the top face and the center of the bottom face. So, it is an imaginary line. Axis is imaginary line passing through the center of the top face and the bottom face. So, that is an axis, lateral edge, and this is the lateral surface. Always in case of prisms, the lateral surface will be always rectangular in shape, and these are the two end faces which are always parallel to each other and which are identical shape and size. Now, axis, when I say axis, axis will be always perpendicular to the face or the base. The axis will be always perpendicular to the base, and always the axis will be parallel to the lateral edges. Okay. So, these are the different part names of prism. Similarly, coming to the pyramid. So, again we have different types of pyramids. So, any pyramid will have a base, okay, and depending upon the shape of the base of the pyramid, we have different types of pyramids. Now, for example, here the base of the pyramid is a square, so we call that as a square pyramid, and if it is a triangle, we call it the triangular pyramid. If the base shape is pentagon, we call it as a pentagonal pyramid. If the base is hexagon, we call it as a hexagonal pyramid. So, any pyramid will have only one base, we do not have any top face as we see in case of prisms. So, we have a base and we have at the top apex, we call this as a apex, and we call this or the slant edges. So, these are the corners of the pyramid. These are the corners of the pyramid. This is the base of the pyramid. This is what we call as a base edge or the side of the pyramid. These are the slant edges, and this is what we call as a slant face. Always in case of pyramids, the slant face will be always triangular in shape, and all these slant edges will start from the base corners and it will touch the apex, and wherever all these slant edges touches, we call that as a apex or vertex. And also we have an axis. So, in case of pyramids, the axis will be imaginary line passing through the apex and the center of the base. So, that imaginary line we call it as an axis, and always axis will be perpendicular to the base. So, even in case of prisms, the axis will be perpendicular to the base. Similarly, even in case of pyramids, the axis will be perpendicular to the base, but whereas these slant edges will not be parallel to the axis, it will be inclined to the axis. Okay. So, that is about the different types of pyramids and different parts of the pyramids. Now, coming to the cone. So, unlike in case of prisms and then pyramids, it does not have, the cone does not have any edges or corners or the lateral edges and so on. So, it is having a base, and base of the cone will be always circle, and we have apex at the top, and we are going to call this as the generators. So, when we rotate a right triangular lamina, the hypotenuse is going to generate the cone. So, therefore, we have n number of generators, but only whenever you take the cone, we are going to draw only two end generators. So, these are the two end generators, this is the apex and this is the base, and again axis is an imaginary line passing through the apex and the center of the base. Okay. And this axis will be again always perpendicular to the base, and they are inclined, means these generators will be inclined to the axis. So, similarly, if I take another solids of revolution, that is cylinder, again cylinder is very much similar to that of a prism, because it is also having two end parallel faces which are identical shape and size. So, always the cylinder will have two circular laminas or circular shape laminas at the end faces, and they are parallel, and it is again bounded by a curved surface. Again, when I keep the cylinder like this, so bottom is this is the bottom base of the cylinder, this will be again top face of the cylinder, again we are going to get the generators. So, again cylinder will not have any base edges or the corners or the lateral edges or the slant edges like other polyhedrons, but here we will have only the generators on the top face and bottom face. Okay. These are the different parts, different types of solids, geometrical solids and its parts. Now, before we conclude this session, so let us define what do you mean by orthographic projection of solids. So, when I say a projection of solids, so in case of projection of planes, what we do is we are going to draw the views of a given plane, that is an object, that is a plane is nothing but an object, on different POPs by using the principles or concepts of orthographic projection. Similarly, in case of projection of solids, so where a solid is an object, now always we assume that the solid which is an object is placed in the first quadrant. It is placed in the first quadrant. You can say this is your HP and this is VP and this is HP and this is the first quadrant. So, the object which is solid is placed in the first quadrant. So, a projection of solid is defined as, it is nothing but obtaining the views, means the front view, top view and side views. It is nothing but obtaining the views of a given solid object on different POPs, that is HP, VP and RPP or LPP. So, on different POPs or different reference planes, we are going to get the views by using the concept or principles of orthographic projection. So, this is all about this particular introductory session of orthographic projection of solids. So, we have seen what we mean by solid, we have seen what are the different types of geometrical solids, and we have seen different types of prisms, different types of pyramids, which are nothing but polyhedrons, and also we have seen some of the examples for solids of revolution like a cone, cylinder and a sphere and different parts of that, and finally we have seen what we mean by orthographic projection of solids. Okay. So, thank you. In the next session, so we'll go ahead with the in detail about the projection of solids. Okay. Thank you.